In this lesson, we want to talk about partial fraction decomposition with linear factors. All right, so when you get to this section on partial fraction decomposition, you might get a little bit confused. It is a bit of a dense topic. It's just one of these things that you have to work a lot of examples on. And so what I'm going to do is split this up. We're going to have this lesson today where we talk about linear factors. This is an easier scenario just to kind of get our feet wet. And then in the next lesson, we'll talk about the quadratic factors, which is a little bit more complex. All right, so to get things started, we already know how to add fractions or how to add rational expressions. We know we need a common denominator. So if I started out with something like 7 over x minus 4 plus negative 3 over x plus 3, we know that we have to get a common denominator, and the least common denominator here would be the product of these two denominators. So x minus 4 times x plus 3. So to add these two, what I would do is I would multiply each fraction by what's needed to have the LCD as its denominator. So in this particular case, I would multiply 7 over x minus 4 by, what's it missing? It's missing the x plus 3. So x plus 3 over x plus 3, right? You got to make it legal. Then plus the negative 3 over x plus 3. So what's this guy missing? It's missing the x minus 4. So times the x minus 4 over the x minus 4. Okay, so at this point, we already know what to do. And I'm just going to kind of write this up here. So if we did 7 times x, that's 7x. And then plus 7 times 3 is 21. And then you have negative 3 times x, which is minus 3x. And you have negative 3 times negative 4, which is plus 12. Now, if you simplify, 7x minus 3x is 4x. And if we did 21 plus 12, you get 33. Okay? So that would be my numerator. And my denominator would be either written as x minus 4 times x plus 3, if you wanted to leave it in factored form. Okay? Or you could go through and write it as x squared. You would have minus x, and then you'd have minus 12. Okay, so you could write it either way. Now, I'm going to erase this factored form. We'll need it in a second, but I just want to present the problem as you will be given it by your textbook or your teacher or however you're getting these problems. Now, we know how to go from this form to this form. But what you want to do now is go from this form to this form. Okay, so you want to take it from this and go to this. This is going to be very important when you get to calculus and start working with integration. Now, what we want to do is first determine if we have a proper fraction. Okay, so in this case, what I'm saying here is that the degree in the numerator needs to be smaller or less than the degree in the denominator. So this polynomial up here has a degree of 1. This guy has a degree of 2. So it's a proper fraction. We're good to go. So once you've determined that you have a proper fraction, you're going to factor your denominator. Okay, so we know what this factors into. It's pretty easy in this case. So 4x plus 33. Again, I'm going to factor the denominator. So it's x minus 4 times x plus 3. Okay, so here's where it gets a bit tricky. For each distinct linear factor, okay, in this particular case, we factor this. This is a linear factor. This is a linear factor. Those are each different. Okay, so for each distinct linear factor, you're going to set up a fraction where that distinct linear factor is in the denominator. So I'm going to have one fraction where this is the denominator. I'm going to have another fraction where that guy's the denominator. Okay, so depending on how many factors you have will determine how many fractions you end up with. Okay, so in this case, I have 2 of these guys, so I have 2 here. Okay. Now, what's unknown up here, those are going to be the constants. So what's going to be over x minus 4? Well, we already know that that's going to be 7. But we don't know that just yet because, again, we're pretending we haven't worked the problem. So we're going to use something like a to represent that unknown. Okay. And then for x plus 3, we know what's on top of that. It's going to be negative 3. But again, we don't know that. So we're going to say that it's going to be b. Okay, so your book uses a and b capital letters. You could use a sub 1, a sub 2, things like that if you want. It really doesn't matter. You're just saying that there's some unknown constant up there that we're going to solve for. Now, there's different ways to solve these. And the way I'm going to show you right here is from your textbook. It does take a little bit longer, but it works every time. Okay, so I'm going to clear the denominators. And the way I'm going to do that is multiply both sides of the equation by the LCD. So if I multiplied 4x plus 33 over this x minus 4 times x plus 3, which would be the LCD. So I'm going to multiply by that, and this would cancel, and I'm just left with this, okay? So I'm just going to erase this as I do this, okay? So this is what I have now. Now, if I multiply this a times this x minus 4 times x plus 3. And again, this is over x minus 4. Well, what's going to happen is this will cancel with this, and I'll have a times this x plus 3. So let me just kind of erase this, and I'll erase that, and I'll say this is a times this quantity, x plus 3, okay? And one more to do. So let me erase this, and we'll do this one more time. So we have b over x plus 3 times, again, this quantity is x plus 3 times x minus 4. So this is going to get erased, and we'll put plus b times, this cancels with this, you have your quantity x minus 4. Okay, so we've cleared all the denominators. So at this point, what you want to do is you want to match your form from this side to this side. So what do I mean by that? Well, you have some number times x, and then plus some constant. Okay, so that's what I want. I want some number times x plus some constant. Okay, and this is going to make more sense in a second. So let me go through and just distribute things. So this is a times x plus 3 times a, and then plus b times x is bx, and then minus b times 4 is 4b. Okay, so over here this is the same, 4x plus 33. Now, what I want to do is get all the terms with x's together so I can kind of factor, okay? So let me show you that. So we're going to have 4x plus 33 is equal to, let's say that we have a times x plus b times x. I'm going to put this as a group, and then plus, I'm going to make another group with just 3a minus 4b, okay? And this will all make sense in a minute. So let's scroll down a little bit more and get some room. So what I want to do now, again, I have this 4x plus 33. So again, it's some number times x, okay, and then plus some constant. So how can I do that? Well, I have this x that I can factor out, right? It's common to here and here. So pull it out. So you have x, and then you're going to have this a plus b. And if you want it to look like this, you can put the x behind it. It doesn't matter, okay? So let's scooch this down a little bit. And then plus, you have this 3a minus 4b. Okay, so what do we have here? Let me just erase this so we can kind of match things up. We have this guy right here has to be equal to this guy right here, okay? Because, again, this equality here says that 4x plus 33 is equal to a plus b, this quantity, times x, plus this quantity 3a minus 4b, okay? So I can just match up this coefficient with this coefficient, okay? And then I can also match up this guy with this guy, okay? That's all I need to do. First time you see this, it does get a little bit confusing, but you work enough examples, and again, it's very, very simple. All right, so let's scroll down and get some room going. And what I want to do now is just say that what? This 4 is going to be equal to a plus b. And I'm also going to say that 33 is equal to this 3a minus 4b. Okay, so basically what I have here is a system of equations. A very, very simple one. So at this point, you can solve this with substitution, elimination, whatever you really want to use. I'm just going to use substitution because I think it's the easiest. So I'm going to actually just copy this because we're going to run out of room, and come over here to a fresh sheet. And I'm just going to say that a is equal to, if I subtract b away from each side, I'm going to have 4 minus b. Okay, so now I can plug in here. So I'll have 33 is equal to 3 times, I'm going to plug in 4a. So I'm going to plug 4 minus b in, then minus 4b. Okay, so we have 33 is equal to 3 times 4 is 12, and then minus 3 times b is 3b, and then minus 4b. Okay, so negative 3b minus 4b is negative 7b. So let's just write that. If I subtract 12 away from each side of the equation, this is going to give me 21 over here. And over here, I'm going to have negative 7b. And if I divide both sides by negative 7, okay, I'm going to find that b is equal to negative 3. And we already knew that because we kind of started out with that information. So b is negative 3. So let me erase this and come back up here. We'll just say b is equal to negative 3. And let's find a now. So if I plugged into this simpler one, 4 is equal to a, and then you have minus 3. Add 3 to both sides of the equation. And of course, we find that a is equal to 7. Okay, but again, we already knew that. So b is negative 3 and a is 7. So if I come back up here and just write my answer, so a is, again, 7, and b is negative 3. Again, the form that we had, we said that we had a over x minus 4, and then plus, you had b over x plus 3. okay? So again, this is equal to this. So we can say this is equal to 4x plus 33 over x squared minus x minus 12. So again, a is 7 and b is negative 3. And again, we already knew this because we started out with this problem in this format. We went this way, and now we've gone in reverse. So that's a simple example. I realize it's tedious, it's time consuming, but you got to work a lot of these to kind of get used to what's going on. Let's look at another example, and this one is going to be a little bit more challenging. So we have negative 15x plus 10 over 9x squared minus 6x plus 1. Okay, so again, the first thing is make sure that you have a proper fraction. So this guy has a degree of 1, this guy has a degree of 2, so we're good to go, okay? The next thing you want to do is factor the denominator. Now you'll notice that this guy is a perfect square trinomial, okay? Because 9x squared is a perfect square, 1 is a perfect square, so you think about this would factor into 3x, and then you would do minus 1, that quantity squared, right? So I'm going to write this as negative 15x plus 10 over, you have your 3x minus 1 quantity squared. Now, I'm going to tell you, whenever you get something like this, you have to be very careful, okay? If you have a linear factor raised to a power, okay, that's not 1. So if it's 2 or 3 or 4, you have to do something called build up the power, okay? So let me explain what that is. Basically, what you want to do when you're setting this up, you're going to take this guy raised to the first power. So I'm going to have my a over this 3x minus 1. Then plus, now I've got to do this again, so b over, now I'm going to do 3x minus 1, but it's going to be squared, okay? Now here's where students get confused. They see this down here, and they just include this, and they leave this off. You don't want to do that. If this was, let's say, cubed, you'd need to do another one. You'd need to go plus c over 3x minus 1 cubed. So you need the first power, the second power, the third power. You're going all the way up to whatever this power is. If this was a 4, you'd put plus. You'd go d over. You'd have 3x minus 1 to the fourth power. You know, so on and so forth. So you've got to be careful when you're working with these guys. This is called a repeated linear factor. So you've got to build up that power. So if it's 3x minus 1, that quantity squared, you've got to have 3x minus 1 to the first power. And also, you've got to have 3x minus 1 squared. So make sure you include both of those. Very important. All right, so I'm going to set this equal to this negative 15x plus 10 over, and you can leave this in factored form. It doesn't really matter. So 3x minus 1 quantity squared. Okay, so let's go through and multiply everything by the LCD. We should be able to do this mentally because it's pretty easy. If I multiply this guy right here by this 3x minus 1, that quantity squared, I know I'm just going to be left with the numerator. So I'm just going to have negative 15x plus 10. Then over here, this is going to cancel. I'm just left with b. Then over here, what's going to happen? Let me do this one kind of manually here because it's hard to visualize. So a over 3x minus 1 times, you'd be multiplying by 3x minus 1. You could say squared, or you could just do this 3x minus 1 again. One of these is going to cancel, so I'll have a times the quantity 3x minus 1. Okay, so at this point, we've cleared the denominators. So what I'm going to do is, again, just stick with the textbook method so nobody gets confused. And I'm just going to distribute the a, so I'm going to have 3ax, and then minus a, and then plus b. This equals negative 15x, and then plus 10. Okay, so at this point, I want to really just group this. I'm going to put this as plus negative here, and I'm going to say that this guy right here is what? It's the coefficient of x in each case. So that means that 3a is going to be equal to negative 15. Divide both sides by 3. And we'll say that a is equal to negative 5. So we already know what a is. Now, how do we find b? Well, you could plug in for a in the equation. Or again, you can just take this negative a plus b and say it has to be equal to 10. We already know what a is, so we're pretty much there. So we would say that negative a plus b is equal to 10. Again, a is negative 5. So the negative of negative 5, got to be careful there because you have a negative out in front, plug in a negative. So this would be plus 5. Plus b is equal to 10. Subtract 5 away from each side, you get b is equal to 5. Let me make that a little better. So a is negative 5 and b is positive 5. So coming back here, we know that a is negative 5. So let me just put negative 5 here. We know b is positive 5, okay? So if you went through and kind of did this addition, you would end up with this exactly, okay? So this is the point we can go from this form to this form and from this form back to this form. Let's look at a different type of example. So now we're not going to have a proper fraction. So what do you do in this scenario? So we have negative 2x squared plus 3x minus 4 and x squared plus x minus 2. So what do we do when this happens, right? The degree here is 2, the degree here is 2. For a proper fraction, the degree in the numerator has to be less than the degree in the denominator. So we're just going to do some long division and work with the remainder. Okay, so it's pretty easy in this case. So you have negative 2x squared plus 3x minus 4. This is only going to take a second. I know everyone hates long division. And then you have this x squared plus x minus 2. Well, really all you're going to be able to do is you do x squared into negative 2x squared. That's going to give you negative 2. Okay, and you're basically done. You're just going to be left with the remainder. So negative 2 times x squared is negative 2x squared. Negative 2 times x is negative 2. Negative 2 times negative 2 is going to be plus 4. But you're subtracting this away. Okay, so remember, you change the sign of everything. I could put a minus out in front, but really I'm just going to drop those parentheses and change all my signs and just add. So that's plus, and this is minus. So what you end up with is this canceling, this being 5x, and then minus 8. So that's your remainder, okay? So really I could write this as negative 2 plus 5x minus 8 over that denominator, which is x squared plus x minus 2. Okay, so we got that part done. And once you're finished with that, you have a proper fraction here. So I'm going to work with this. Don't forget the negative 2 part. It's very important when you report your answer. But for right now, we're just going to work with that proper fraction. So 5x minus 8 over x squared plus x minus 2. So we know it's proper. So factor the denominator. This guy's going to factor into what? So it's going to be x here and x here. I know that it's going to be plus 2 and minus 1. Okay, so let's just erase that and move this up here. And again, what do we do? Well, for each distinct linear factor, I've got to have a fraction with a denominator with that guy. So I'm going to go a over, you've got x plus 2, plus b over, you've got x minus 1. Okay, so if I go through and clear the denominators, again, the LCD is going to be this guy right here. So I know in this case, it would clear it. So I would just have 5x minus 8. In this case, the x plus 2 would cancel with the x plus 2. So I would have a times the quantity x minus 1. Okay, and then in this case, I would have the x minus 1 cancel with the x minus 1. And b would multiply by x plus 2. So plus b times x plus 2. All right. So we got that worked out. So let's just distribute now. So this would be ax minus a plus bx plus 2b. Again, this equals, you have your 5x minus 8. Okay, so let me get everything with x together. So I would say this is a times x plus b times x. And then plus, I'm going to group these together. So negative a plus 2b. Okay, so let's write this over here. And again, all I'm trying to do is relate the two sides. So this coefficient here is going to relate to this guy over here that I'm going to set up. I'm going to say this is a plus b out in front times x. Okay, all I did was factor the x out. And let me just kind of make this a little better. So we have 5x minus 8 equals, so this is equal to that. Okay, then plus, this is going to be your constant. So your negative a plus 2b, that's your constant. So this is going to relate to that. Okay. So once you've set this up, and again, you just need to work a lot of examples so you get used to this. All you need to do is say that, okay, I know that a plus b is equal to 5. And I know that negative a plus 2b is equal to negative 8. Now, this is a system, and you do have to spend a few seconds to solve it. It's not too bad. I know a plus b equals 5, so a, if I wanted to solve for that, is what? It's 5 minus b. So if I plugged in for a here, I would have the negative of 5 minus b, and then plus 2b is equal to negative 8. So let's go ahead and solve this really quick. So I'd have negative 5 plus b, and then plus 2b is equal to negative 8. So this would end up being 3b. And if I add 5 to both sides, I would get negative 3 over here. So this is negative 3. If I divide both sides by 3, I'll find that b is negative 1. Okay, So let's erase everything here. We don't need any of this. So if b is -1, so if this is -1 or -1, then what? I add 1 to both sides, and I find that a is equal to 6. So b is -1 and a is 6. Okay, so here's where you got to be careful with this when you write your answer. Remember, we did a division first, so you got another part to this. So the a is going to be 6, and the b is -1. I'm just going to erase this real quick. Remember, this is only part of your answer. So if you come back up here, you had this, okay? So what I'm going to do is I'm going to say this is -2 plus this right here, okay? So this right here, and you can erase this part, is equal to this, okay? So your -2x squared plus 3x minus 4 over x squared plus x minus 2 would be equal to -2 plus 6 over x plus 2 plus -1 over x minus 1. Again, don't forget this part here. It's very important to have a full answer. I know a lot of students, they run through these problems, they forget the -2, and then they get points off. Okay, let's run through one more problem. This one is not harder, but it's more time consuming. You'll get these sometimes. So you have -x squared minus 30x minus 13 over x cubed minus x squared minus 5x minus 3. So it is a proper fraction, so we don't have to do any division to start. But when you go to try to factor the denominator, it's not something you can factor with grouping. This is something where you have to do the rational roots test, okay, and then start using your synthetic division to go through it. I don't want to make this video any longer than it needs to be, so I'm just going to tell you in advance that this guy is going to factor into x plus 1, that quantity squared, let me make that better, and then times your x minus 3. Okay, I'm just going to put that out there. Again, if you're working these in a workbook or something like that, you're going to have to take the time to use your rational roots test and then go through the possibilities to see if you can factor this guy. All right, so once you've figured this out and you have this factored, again, all I'm going to do is I'm going to say, let me just kind of move this over here. And let me put this up here. So -x squared minus 30x minus 13. Okay, so again, what I was saying is all you want to do is set this up where each one of these guys, each distinct linear factor, has a fraction where it's in the denominator, okay? But again, if you have something with a power here, it's raised to the second power, so I need x plus 1 to the first power, and I also need x plus 1 squared. Again, if this was to the third power, I would need x plus 1 to the first power, x plus 1 to the second power, and then x plus 1 to the third power, right? So on and so forth. So what I'm going to do is I'm going to say that I have a over, I've got my x plus 1, and then plus b over, I've got my x plus 1, that quantity squared, and then plus my c over, you got your x minus 3. Okay, so this is the setup for this one. It's going to be a little bit more time consuming. So let me just kind of scroll down just a little bit. I'm going to try to fit everything on the screen. So we know that we would clear the denominator, so this would be equal to this. I'm not going to be able to fit that side by side, but if we multiply both sides by the LCD, we know that this is going to cancel completely. So I'm just left with this numerator. So I'm going to squeeze this in and say we have -x squared minus 30x and then minus 13. Okay, so then equals. For this guy, when I go through and multiply each one of these guys by the LCD, you can think about what's going to cancel. Well, in this case, I have one factor of x plus 1. Here I have two of them. So I would have a times one factor of x plus 1 times this x minus 3. And I'm not going to fit all this, so I need to go through and simplify each time. So this would be what? This would be x squared, and then this would be minus 3x, and then plus x, and then minus 3. So this would be minus 2x right here, and then minus 3. Okay, so from this point, let me just kind of erase this. We know that a would multiply that. So minus 2x minus 3. And if you wanted to, you could go through and distribute it now, but I'm going to do it in a minute. So then you move on and you have plus b over this quantity x plus 1 squared, again, times this LCD. So this cancels with this, and you have the x minus 3. So b times the quantity x minus 3. Okay, and I'm not going to be able to fit this in one row, so I'm just going to continue this down here. So I'm just going to draw a little arrow, say we've got to go down there. So now what I'm going to have is the x minus 3 cancel, and I'm going to have c times, I'm going to have this x plus 1, this quantity squared. Okay, so let me scroll down a little bit now that we have everything. We'll get some more room going. All right, so I'm going to have -x squared minus 30x minus 13, is equal to, I'm just going to distribute this to everything. So ax squared minus 2ax minus 3a, and then plus you've got bx minus 3b, and then plus, I'm going to continue this down here. Now, you should expand this to not make a mistake. A lot of students will just say this is cx plus c. Okay, that's wrong. Remember, this guy means you have to FOIL it out. So really, I could say this is x squared plus 2x plus 1. What this would turn into down here is cx squared plus 2cx plus c. What you want to do here is just think about the fact that you have a negative 1 for the coefficient for x squared, a negative 30 as the coefficient for x, and a negative 13. So you want to just match the format of what you have on the left side, okay? In some cases, you might not have a quadratic over here, but you might have a quadratic over here. And in that case, what you're going to do is you're going to treat it like if you had 0 on this side, okay? So if you didn't have an x squared over here, you would just say that you had 0x squared, okay? And then 0 would be matched up, okay? But that's not what we have here. This is a little bit easier. And basically what I want to do is say I have my negative x squared minus 30x minus 13 is equal to, so everything with an x squared. So you have ax squared and you have cx squared. So I'm just going to have a plus c as that coefficient, and then times x squared. And then I'm just going to check these off as I go so I can keep track of what I've used. Then I'm looking for everything with an x. So you've got an x here, and also here. Okay. So we would do plus, I'd have negative 2a, and then plus b, and then plus 2c, and then times x. Again, all I'm doing is I'm taking these terms. You can imagine I'm just writing them next to each other. I'm just factoring the x out. So the x is just being pulled out in each case, and it's outside of a set of parentheses. That's all I'm doing. Okay, then I'm going to continue this down here. So plus, now we're going to have everything that's kind of a constant. So this is gone, and this is gone. So now I have negative 3a, negative 3b, and c. So negative 3a, I have negative 3b, and I have c. Okay, so now we have something where we can go through and set up a system. So we know that, again, we're just kind of equating the two sides. So this is negative 1 here, and you can say that this has to be equal to this. So I know that a plus c has to be equal to negative 1. I know that this right here, the coefficient for x, has to be equal to this negative 30, okay? So I can say that negative 2a plus b plus 2c is equal to negative 30, okay? And then I know that this guy right here, okay, which represents the constant, is going to be equal to negative 13. So negative 3a minus 3b plus c equals negative 13. Okay, so let me copy this because we're definitely going to run out of room. And let me just go over here to a fresh sheet. And we can solve this system pretty easily. What I'd want to do is take these two right here and eliminate b, okay? That would give me a linear system with just a and c, right? So I'm going to add these two together. And what I'm going to do is just multiply this top equation of these two by positive 3, okay? So if I do that, I would have negative 6a, and then plus 3b, and then plus 6c, and this equals negative 90, okay? So then I have this negative 3a minus 3b plus c equals negative 13. Okay, so if I add these two equations together, what I'm going to have is, this would be negative 9a, this would cancel, I would have plus 7c, and this equals, this would be negative 103. So now, let me just kind of write this over here. I have negative 9a plus I have 7c, and this equals negative 103. Okay, so that's going to allow me to find a and c. So what I'm going to do, let me just kind of drag this down here. Put it off to the side. I'm going to solve this for a, and I'll say that a is equal to negative 1 minus c. And then I'm just going to plug in over here. So negative 9 times this negative 1 minus c. And then plus 7c equals negative 103. Okay, well, this would be positive 9 plus 9c. And then plus 7c equals negative 103. 9 plus 7 is 16, so this would be 16c. And then if I subtract 9 away from each side of the equation, I'm going to have that 16c is equal to negative 112, divide both sides by 16. I'm going to find that c is equal to negative 7. Okay, so we know what c is. So C is negative 7. Okay, so what's A? Well, if I plugged in a negative 7 there, we'd have A minus 7 equals negative 1. Add 7 to both sides. You get A is equal to 6. So A is 6. Okay, so at this point, you can kind of get rid of everything except for this equation here. You could really use either equation with B, but I'm just going to use this one. So I'm going to plug in now. So I'd have negative 2 times 6 plus B plus 2 times negative 7 equals negative 30. Let's just get rid of that. We don't need it. So we'd have negative 12. And then 2 times negative 7 is negative 14. Negative 14 plus negative 12 is negative 26. So let's put negative 26 plus B equals negative 30. Let's add 26 to both sides of the equation. So this is gone, and we find that B is equal to negative 4. Okay, so B is negative 4. All right, so now we found A, B, and C. Again, some of these are going to take a very long time. Okay, so we come back up here, and again, C was negative 7. So you can either put minus 7 like this, or you can put plus negatives. It doesn't matter, whatever you want to do. A is 6, and then B is negative 4. So again, you can just put minus 4 like this. So when we write this out, we can say that our negative x squared minus 30x minus 13 over x cubed minus x squared minus 5x minus 3 is going to give us this 6 over x plus 1, and then minus 4 over x plus 1 squared, and then minus 7 over x minus 3.